Our material is moved with overhead cranes. Please watch for all crane movement during your tour. The raw material for the hot mill is cut at the cold saw. The material is cut based on the weight needed for the reduction and elongation to gain the dimensions of the ordered product. From the cold saw, the material is transferred to the furnace charge table. The billet is then loaded into the Salem walking beam furnace. The furnace can hold 5-foot to 14-foot billets and will heat up to 15 tons per hour. The billet will exit the furnace at an average temperature of 2150 degrees. The billet then proceeds down the roll line to the piercer inlet. The piercer is an Etna barrel type piercer with twin 1500 horsepower. During the piercing process, the rolls compress and pull the billet through and across a piercer point. The rolls and piercer point settings provide the hollow size needed to be transferred to the disher. The shell is transferred across the transfer table to the disher inlet. The disher mandrel bar then guides the shell into the disher where the rolls and disc reduce the OD of the shell while thinning the wall to the size needed to meet the customer's ordered thickness. The disher is a restrained mandrel mill made by Cox Engineering in Germany. As the shell exits the disher, the stripper clamps hold the hollow. As the disher bar is stripped from the shell, it drops to the roll line. From the disher exit, the hollow moves along the drive line to the entrance to the induction coils. The induction coils are powered by two 3000 kilowatt Ajax units. The induction units are necessary to replace the heat loss because of the time span from the disher exit to the CSM inlet. The recommended temperature entering the CSM is 1700 degrees. The CSM controlled sinking mill was also produced by Cox Engineering. As the shell exits the CSM, it passes through the IMS unit. The IMS unit measures the average dimensions for the OD and wall. This information is fed to a computer at 2 mill locations. The information can be used to make quality adjustments during the production process. The shell is then transferred to the cooling table where it is air-cooled. The average temperature of the shell coming to the cooling table is 1700 degrees, and it will roll off the west end into the packing bucks at an average of 900 degrees. All hot mill material goes through an acid bath dip to remove excess scale from the OD and ID surface before going to either the hot mill finish department or transferring to our cold draw facility. The straightener is a Sutton 618 6-roll rotary straightener. This is the first process in our finish department. All hot finish product is non-destructive tested for OD surface imperfections using the eddy current. We also utilize the ultrasonic test for testing through wall and ID surface imperfections. The hot mill has two Forte digital controlled band saws where the material is cut to length. Although there are quality checks built into the process, we take the time to check the material one last time at the final inspection station. All actual dimensions are recorded and a visual inspection of the material is completed. All material is put in a hex-shaped bundle and moved to finished goods storage in preparation for shipment. Hot finish material is available in various grades with a size range of 1.99 to 5-inch OD and wall thicknesses of 0.200 to 1-inch average walls. We do appreciate your coming to visit our facility. Have a safe and enjoyable visit.